find the equivalent resistance of the given circuit. So this is the circuit given. We have to find out what is the net resistance of this one. So this is, we can write this one point. This is point A. Point A, it is branch out to B and it is branch out to D. So it is from point A, this is D, branch out to D and branch out to B. Branch out to B. And the resistance is R, because from A it is going to D, from A it is going to C. Now let us see from C. From C it is going to, from C, this is a junction, so this will be different point. So from C we call this point, because this will be also C only, because same potential, because there is no resistance, whatever the potential, same potential will available here. You can say from C it branches to D, branch out to D, and it branch out to B. So we can say from C branching out to, this is C branching out to D, from C again to B. Again to B, this is the resistance R, and this is the terminal A and C. Now what about B and D? So there is a resistance between B and D. So we will draw this one between B and D. All the values of resistance is R. It means this is forming a Wheatstone bridge. Whether it is balanced condition or not, let us see. This divided by this should be equal to this divided by this under balanced condition. Under balanced condition of Wheatstone bridge, either this divided by this or this divided by this, we can say R divided by R is equal to R divided by R is equal to 1. This divided by this is equal to this divided by this, or this divided by this is equal to this divided by this. So this it is in balanced condition. So when it is balanced condition, potential at D is equal to potential at B, because no current will flow in this branch, so this is useless. We can remove this one. You can remove this one. It means this, there is one branch, this and these are in parallel, this and these are in series. So we can draw this circuit diagram as from A, there is R plus R, this is in series, that is 2R, R plus R 2R into C, again A to C, R plus R 2R, one more is in series. So this is a net circuit. So this is 2R, both are in parallel, therefore resistance between R, A and C is equal to, both are same identical resistance. It means take any one of the resistance and divide by number of resistance is equal to R. Therefore R equivalent of this circuit is equal to R. R we can say 1 by R AC is equal to 1 by 2R plus 1 by 2R is equal to 2 into 1 by 2R is equal to 1 by R. That implies R between AC is equal to R. So we can calculate, this is the fastest way, this is the our normal way. We can calculate any another method. Therefore the net equivalent or equivalent of this entire circuit is equal to R. Find the current in the given circuit. So this circuit we will draw it. See, this is the point A, there is a resistance, so the potential at this point will be different. The potential at this point will be different. We call this point as B. Same is the case, this we call it as a C, and again this is as a D. Let us draw the circuit between A and C. See, this is A and C. Between A and C, there is 5 ohm resistance. Again, between A and B, there is a 10 ohm resistance. That in between B and D, we call it as D. Between B and D, 20 ohm. 20 ohm. And between D and C, 10 ohm. 10 ohm. Between B and C, there is one more 10 ohm. 10 ohm. Let us check up A and C, 5 ohm, A and B, 10 ohm, and B and D, 20 ohm, and B and C, 10 ohm, and a potential, a EMF battery is connected here of 5 volt. 5 volt battery is connected. Now let us see whether the bridge, Wheatstone, this forms a Wheatstone bridge, 4 arms with the center arm. Let us see P by Q, R by S. P by Q is equal to R by S. Let us check up, that is P by Q, that is 5 by 10 is equal to 10 by 20. Yes. The Wheatstone bridge is under balanced condition. Why? This divided by this divided by this resistance divided by this resistance, or this is equal to this resistance divided by this resistance are equal. It means this branch between C and B can be removed. It is of no use because potential at C is equal to potential at B. It means no current, that is no current. No current flows across this bridge, so this we can remove it. Now these and these are in series, that is we can write it as 5 ohm and 10 ohm as in series. We can write 5 plus 10 is equal to 15 ohm in series, that is point A, and again 10 plus 20, this also in series, and both are in parallel with the D, and this is the potential up, this is the battery of 5 volt. So we have to find out the current. Since these and these are in parallel, we can write R equivalent. R equivalent is equal to multiply these two, 15 into 30 divided by 15 plus 30, 45. That is, this is equal to 3 times, and this is equal to 10 ohm. So now we can draw this circuit like this, and net R equivalent and the EMF of the battery. So this is the point A and this is the point D. The net is equal to 10 this is equal to 5 volt, and this is I. So this is I. So I is equal to net voltage divided by R equivalent. Net voltage is equal to 5. That R equivalent is equal to Z is equal to half is equal to 0.5 ampere. So this is the current is equal to 0.5 ampere. A DC source with internal resistance R naught. Internal resistance is equal to R naught. Loaded with 3 identical resistors R. Loaded with 3 identical resistors. It means the equivalent resistance of this one is equal to external resistance. External resistance is equal to R equivalent of this, all 3 identical resistance. For what value of R will the thermal power generated in the circuit will be highest? As it is, we have seen in the battery, for maximum power means power is generated, heat is generated. Thermal power means because due to power the heat is liberated, that's why it is called thermal power. For maximum power, it means internal resistance equal to external resistance. This already we have seen. For maximum power, thermal power generated in the circuit will be that this generation should be maximum. Now let us find this one as A, and there is no resistor, so this will be also point A. If we call it as B, this will be also B. Now let us draw the circuit. The circuit is between A, this is, we call this point as A. Between A and B there is a resistor. A and B there is a resistor whose values are A and B. That in between A and A, one more resistor. Between A and B, one more resistor R. Again between A and B, one more resistor R. So the R equivalent is equal to 3 resistors are in series. It means all are identical. Means take any one of the resistor divided by number of the resistor. So R equivalent is equal to R. So now we can draw the circuit diagram like this. This is a battery with internal resistance R naught, battery with EMF, and the external resistance whose value is equal to R by 3. As it is for maximum power dissipation, the internal resistance must be equal to external resistance. What is internal resistance? This is internal resistance is R naught, and external resistance connected. This entire circuit is connected like this, R by 3. So this external resistance must be equal to internal resistance. That is, R external resistance should be equal to internal resistance, then only maximum power is dissipated. It means we can come that R is equal to 3 times of R naught. This is the condition.